When factories build live steam models, they're reconstructing history. These working steam models take us on a nostalgic journey. And they're fun for hobbyists of all ages. Add a little water, light some fuel for the boiler, and it's full steam ahead for this mini replica of a 19th century road locomotive. Production starts with the boiler. A hydraulic press repeatedly punches a piece of brass, stretching the brass cap into a cylinder. It's a process called drawing, and it also strengthens the metal. A flat piece of brass is transformed into a cylinder in only a few minutes. Next, the ends of the cylinder are trimmed. Solder paste is brushed onto a brass cap and slotted into a holding device. Paste goes onto attachments inside the cylindrical boiler. Then the boiler and cap are press-fitted together. The cap boilers travel through a furnace, which melts the solder paste, fusing the caps to the cylinder. Workers polish the brass to give it a nice sheen. Then they solder copper pipes to the boiler. These pipes will expel the steam as it powers this little locomotive. Next up, trimming the flywheel, which has been precast. The flywheel will smooth out the engine's firing impulses so that it runs more evenly. The flywheel is tightly screwed to the crankshaft. Workers check the sliding action of the piston and its cylinder. Then, they attach the assembly to the engine frame and the crankshaft. Lubricating the piston assembly enhances its sliding action. Using compressed air, workers make sure the engine functions and has no leaks. Once the model passes the test, it gets its front steering mechanism. This will control the model's front wheels, while the back wheels power it forward. Steam machines are usually rear-wheel drive. A wire called the drive band transfers the energy from the flywheel to the rear wheel. The steam model is hooked up to the compressed air tank once again for a final test run. And it looks like this model is ready for some action. All it needs is a canopy to provide a little shade. A rib design is punched into a little steel roof. After it gets a nice paint job, it's attached to the model. Production on this tiny treasure is now complete. This model will also take you back in time, but in high style. It's a luxury touring car. Workers install the piston cylinder assembly a little lower on this roadster and fire it up. Each of these mini steam models is a tribute to the original and give us all a glimpse into the colorful history of transportation. Strobe lights often conjure up images of 70s discos. But you'll also find strobe lamps, the proper term by the way, on aircraft wings, in police lights, and on towers and tall buildings to warn low-flying aircraft. Strobe lights even play a role in photography and on factory production lines. A strobe lamp emits repeated flashes of high-intensity light. At this factory, production begins with glass blowers. Using a ribbon burner, they heat glass tubes to almost 3,000 degrees. This softens the glass for bending. But if it's too soft, the tubes will collapse, so the glass workers blow air into it through a rubber hose to build counterpressure. The size and shape of the glass tubes varies by model, but its job is always the same: to house a strobe lamp's essential components: electrodes, lead wires, and xenon gas. The electrodes conduct the current, which charges the gas with electricity, making it illuminate. This factory makes several strobe lamp models, some in large quantities for the mass market, others in small quantities custom designed for specific clients. With mass-produced models, automated machines take over after the glass blowing. Custom orders are handmade from start to finish. Workers even make the electrodes manually. They weigh a precise amount of metal powder and pour it into the cavity of a press similar to what pharmaceutical factories use to make pills. This powder is a blend of several different materials, but the company won't divulge the ingredients. The press applies 4 tons of pressure, compressing the powder into a pellet. The factory inspects every pellet to ensure it meets quality standards. The pellets then undergo a hardening process called sintering. They bake for 9 minutes in a hydrogen-fueled oven. Hydrogen is one of the hottest types of fuel, and the 3,000-degree heat fuses the powder particles into a solid mass that won't crumble apart. Next, workers weld a lead wire to each electrode. Then they insert 2 electrodes, one for the positive current, one for the negative, into each glass tube. Then they melt the end of the tube closed. Then they attach a wire called a trigger lead. It prompts a transformer to send a high-voltage electric pulse to the electrodes, illuminating the gas. This automated machine assembles the factory's mass-produced models. Before starting it up, workers load the components: a pair of electrodes, followed by a glass tube on top. Now, the machine takes over. It vacuums out the air in the tube, injects xenon gas, melts the tube closed, then cuts off the excess glass. The tube's interior must be completely free of contaminants for the gas to illuminate. So just before the vacuum fill and seal operation, a hot coil encircles each tube to burn away any impurities. On custom-made models, all of these steps are done manually. With a strobe lamp complete, it's installation time. This model is for the warning lights you see on tow trucks and road construction vehicles. It goes into a glass reflector lined with metallic film. A transformer regulates the voltage. Its 3 wires connect to the positive, negative, and trigger leads protruding from the lamp. A glass lens cover seals and protects the lamp within the reflector, and then this product is good to go. Strobe lamps are also used in stroboscopes, industrial devices that help factories perform quality control inspections on high-speed production lines. Calibrate the light pulses to the right interval, and they appear to stop the action, so that cameras or workers can examine the goods. It's the size, shape, and configuration of a strobe lamp's components, along with voltage and other electrical specs, that determines how long, how often, and how quickly the light flashes.
In today's world, suits are common, allowing both men and women to dress the part for any situation, everyday work, or a special occasion. While men and women may wear different parts of a suit, the basics of the suit have been unaltered for over a century. A jacket and trousers or skirt, it's a look that's never out of style. Every suit begins with the design on paper. The style is precisely sketched. It's a creative process, but also highly technical. He plans the entire outfit, right down to the last stitch. No detail is left to chance here. They feed the design data to this computerized cutting machine. The blade slices through fabric placed under paper. And because it's computerized, it's very precise, producing pieces that will fit together like a puzzle. This is how they used to cut the fabric, by hand. It was more time-consuming and the margin for error was much greater. Now it's time to reinforce the fabric. She places fusing tape made of fabric onto a sleeve piece and then sends it to a heat chamber with rollers that will bond the tape to the material, giving it strength. Next, it's over to the sewing machine. A worker lines up 2 sleeve layers and it's hands-free from here. A rail powered by compressed air descends and guides the fabric under the needle. A computer controls the sewing. This frees up the operator to continuously feed the machine. This is an automatic pocket welt machine. She places the front of a jacket under a clamp and puts the welt fabric in the clamp and a pocket flap at the side. The clamp automatically slides the fabrics to needles that sew the welt and flap onto the jacket. Then 2 tiny knives emerge and cut the pocket open. The result, a precisely made pocket, completely by automation. The only human involvement is to feed the machine and then collect the finished product. Now, over at another station, an operator irons fusible tape onto the open seams. This stabilizes them and gives them a crisp finish. A worker places the front of the jacket on a headless mannequin called a buck. A hot metal press moves in, and the pressing reshapes the jacket to the contours of the buck. Now she puts a sleeveless jacket on another buck and tucks a shoulder pad underneath. She presses a pedal to activate the machine, and the hot presses lower, melting the glue on the shoulder pad, which fuses it to the jacket. Now to steam the fabric. Another jacket is on another mannequin, and a worker clamps down the sleeves. A big steam bag made of porous vinyl swings in, wafting steam onto the front of the jacket. At the same time, hoses pipe steam into the porous mannequin cavity, so this jacket gets a steam press from both sides. This machine is a collar master. She folds the collar into the correct position and lowers a big fabric-covered metal press onto the collar to iron down the fold. It's time for the auto jig machine. It's making an extension piece to the second button for a pant waistband. This is the piece that goes over the second button on the waistband of dress pants. It sews and cuts 2 layers of fabric that are held in a jig, and then feeds the excess fabric to a vacuum tube for disposal. Now it's time to define a crease in a pair of trousers. An operator slides a pair of pants inside out onto a double rail. Then, using a device similar to a caulking gun, she pipes a silicone-based liquid along the crease line. The liquid is a permacrease mixture which will give the crease some staying power. There's also a nib on the end of this gun which sharpens the crease. All that stitching and steaming seems to have gone without a hitch. But the designer still needs to inspect the work to see if it measures up to his original concept. If adjustments have to be made, he marks the spots. That's because how it fits can be just as important as how it looks. The Swiss call this cheese fromage d'alpage, which means cheese from the high mountain pastures. Master cheesemakers retreat to their chalets high in the Swiss Alps to make this special cheese. These individuals follow a tradition of cheesemaking that goes back to the Middle Ages. Fromage d'alpage is produced by cheesemakers who bring their cows high into the Alps for 5 months to this region of Gstaad, Switzerland. In the morning, they milk their cows for about 7 minutes using an automatic milking machine. Each cow produces around 2.5 gallons of milk, which contains water, protein, and fat. "12 hours later, he removes the fat, which rises to the surface. He adds a starter culture which helps preserve the milk. A wood fire then heats the milk for 20 minutes at a constant 86 degrees Fahrenheit. He then adds an enzyme called rennet and more starter culture to the milk. After about 40 minutes, these active ingredients coagulate the milk into cheese curd. He cuts the solidifying curd into smaller pieces. To maintain an even heat, he keeps blending the curd and the liquid together. He continues mixing and cutting the curd until the active ingredients separate the curd from the liquid called whey. To make cheese, he will use only the grains of curd. An electric mixer then completes the separation. He washes his arms and hands thoroughly because any impurities in the cheese would ruin it. After heating the mixture for 20 minutes again, the curd is now the perfect texture for making cheese. Using cheesecloth, they remove the grains of curd. What started out as 80 gallons of milk will end up producing only 66 pounds of cheese. The cheesemaker stuffs the sack of curd into a mold and works out some of the whey. He then puts 3 molds filled with curd into a wooden press. And using a wooden block that distributes the pressure evenly, he squeezes out more of the whey. To get all the excess liquid out of the curd, he turns each 22-pound piece of cheese over so he can press it again. Too much liquid in the cheese would affect its shape and quality, so he does this a few times, then leaves them in the press overnight. The next morning, he trims off the excess cheese created around the edge by the pressing mold. Like every step in this cheese-making process, this work is also done by hand. He soaks the cheese in salt water for 24 hours to conserve, harden, and intensify its taste. The cheese then goes through a salting and maturing process that lasts 6 months. During this time, they flip each piece of cheese often so it ages evenly. After a final surface cleaning, they put the 22-pound pieces on their sides to air dry. They'll remain edible for at least 10 years. But of course, you don't have to live in the Alps to enjoy the taste of Swiss cheese.
For thousands of years, wars were won and lost by the sword. Swords helped shape history. Today, modern artisans craft historical replicas of these age-old weapons, and they go to the hilt to make sure the details are just right. This reproduction of a medieval sword harkens back to the days of knights in shining armor. The first step to making a sword is to place a piece of high-carbon steel in a fixture. Computer-guided blades carve out the basic shape of the sword with all the specifications of the original. Centuries ago, a blacksmith would have done this painstaking job by hand, but this machine is much faster and creates a much more consistent cut. After about an hour of carving, a nicely tapered sword blank emerges. The blank is submerged in hot liquid salt, a critical step that softens the steel to eliminate stresses created by the carving. Next, the blade is plunged into cool liquid in a process called quenching. It immediately hardens the edges of the sword, but the center cools more slowly. This allows the sword to retain flexibility, giving the blade a springy quality. Using a belt grinder, sword makers fine-tune the blade's shape and hone its edges. The blade is now incredibly sharp. To test its strength, they strike a metal barrel with it. Incredibly, the sword doesn't chip. Next, wax is pumped into molds to make historically accurate copies of the hilt parts. Like the pommel, which is the counterweight at the end of the hilt, and the guard that separates the blade from the handle. These wax copies are used to cast the parts in metal. Then the cast metal pieces are smoothed and polished. They smooth away the rough edges on this sword guard and hone its profile. Grinding the pommel is a challenge because it has so many curves and angles. One mistake and the pommel could end up lopsided, which means it wouldn't be very effective as a counterweight. With the blade in a padded vise, the guard slides onto the tang, where it's cushioned with a piece of plastic and a metal pipe. Then, a sledgehammer pounds it into position. Next, the pommel is hammered into place. And finally, a small piece of steel called a peen block is slipped on. Heat from a torch softens the peen, so it spreads as it's hammered down. Epoxy gets a quick stir, then it's applied to two wooden grips as well as to the handle of the sword. Then the grips are clamped into place. Next, black dye is brushed onto a thin piece of leather. The other side is coated with glue. This glue and dye-drenched leather is then wrapped around the wooden handle. It's bound with cord to compress the leather wrap while it dries. Now it's time to brand the blade with the maker's insignia. Chemicals etch the mark into the steel 4/100th of an inch deep. And now you have a replica that's true to the medieval original. A piece of art that takes you back in time at sword point.